All right, we're going to look at adding and subtracting radicals. So let's look at some background. What if we were asked to simplify 6x squared plus 4y minus x plus 5x squared minus 7y plus 9x. To simplify that, we would be looking for our like terms. So, let's see, what are our like terms? Well, we've got 6x squared and 5x squared. That gives me 11x squared. So let's look for the x's. I have a negative x here, plus 9x here. That gives me 8x. Let's see what else we have. We have 4y and negative 7y. That gives me a negative 3y. Now, I want you to compare that to, what if we had 6 square roots of 2 plus 4 square roots of 3 minus the cube root of 2 plus 5 square roots of 2 minus 7 square roots of 3 plus 9 cube roots of 2. Now look at how similar these problems are. Coefficients all the way down are exactly the same. Instead of having variables, though, we have radicals. They add and subtract just like you did with variables. You have to only add and subtract like terms. So do you see the square roots of 2? I have 6 square roots of 2 and 5 square roots of 2. That means I'm going to have 11 square roots of 2. Let's look for the square roots of 3. I have 4 square roots of 3 here, and I have negative 7 square roots of 3 here. That's going to give me, whoops, I kind of did it in the wrong order, but that's okay, negative 3 square roots of 3. We have negative cube root of 2, and then plus 9 cube roots of 2. That's going to be 8 cube roots of 2. Now, just like when we were combining like terms with variables, those coefficients are really just telling us how many of them we have. When we're counting them or adding and subtracting them, it doesn't change those things. It's sort of like if I had 6 apples and 5 apples, I'm going to have 11 apples. I don't change the apples suddenly into oranges or bananas. You can only combine like terms, and really all we're doing is counting. Now, the next thing I want to compare, what if we had 3x plus 5 times 7x minus 9? So minus 9. We would distribute. Okay, so let's distribute. 3x times 7x would give me 21x squared. 3x times negative 9 is negative 27x. Then 5 times 7x is 35x. And then 5 times negative 9 is going to be negative 45. And now we can combine our like terms. There's 21x squared. Then negative 27x plus 35x gives me 8x. And then we have minus 45. Now, I want you to compare that to the next problem. What if we had 3 square roots of 2 plus 5 times 7 square roots of 2 minus 9? What do you think we're going to do? Same exact thing. We're going to distribute and then combine our like terms. 3 times 7 is going to give me 21. Square root of 2 times the square root of 2 is going to give me the square root of 4. Then 3 square root of 2 times negative 9. Negative 27 square roots of 2. 5 times 7 square root of 2 is going to be 35 square roots of 2. And then 5 times negative 9 is negative 45. Now, what's nice here is square root of 4 is 2, 2 times 21 is going to be 42. Combine our like terms, and we'll get 8 square root of 2, and then minus 45. And then we get to combine like terms again. We have 42 and a negative 45. That's going to give me a negative 3. So the principles are exactly the same as they were when we had variables. The thing that we're going to have to make sure of is what we think of when we have like radicals. What's going to make them alike? So, if you notice here, these were alike because they have to have the same radicand. These are not like terms because this one's a square root and this is a cube root. So not only do they have to have the same radicand, they have to have the same index as well. Now sometimes when you see them, they're already alike, and sometimes we might have to simplify them a little bit to make them alike. So let's see if we can look at some examples here. Example 1. Let's start off with square roots then. Square root of 6 square roots of 18 plus 4 square roots of 8 minus 3 square roots of 72. Alright, so we look. Are they alike? No. Can they simplify? Why, yes. I know 18 is really 9 times 2. Now, I know I could keep breaking this down, but isn't 9 a perfect square? It is. That means I'm going to have 3 square roots of 2, which gives me 18 square root of 2. Now for the next one, 8 is going to break down to 4 and 2. That's a perfect square. I know it's 2 times 2, which is a pair, so that 2 is going to come out, and I'll have 2 root 2. There was a 4 already out there, so 4 times 2, that's going to be 8 square roots of 2. The next one, 72. Ooh, I wish it was divisible by 2. Oh, it is. 36 and 2. Hey, 36 is really 6 times 6. So 6 can come out, and the 2 stays in. So that's going to give me minus 18 square roots of 2. Now I have like radicals. The 18 square root of 2 minus 18 square root of 2 is going to go away. Be left with 8 square roots of 2. Let's look at another example. Let's throw a little bit of a curveball in there. 4 square root of 18x minus square root of 72x plus square root of 50x. Same thing. Simplify your radicals first. That's 9 and 2. So 3 is going to come out. Now if you notice what happened here, when the 3 comes out, 3 times 4, that's going to give me a 12. The 2 stays in with the x. Here, we already found that one. That's going to be 6 square root of 2x. And then we have 50. 50 is really 25 times 2. 25 is really 5 times 5, so that 5 gets to come out, and 2x is still in there. Do we have like radicals? We do. So we can add and subtract them. 12 minus 6, that gives me 6, plus 5, gives me 11 of those things. The radical does not change when we add and subtract them. Let's continue with some more examples. Let's say I had, this would be number 3, cube root of 64xy squared plus the cube root of 27x to the 4th y to the 5th. Alright, so we look at it first. Can we add them together? Well, no, not right now. They're not like radicals. Now, they do have the same index, but they're not the same yet. So I need to try to simplify them. So I look at 64. That's 16 times 4. That's 4 times, oh, I should have known. That's 4 cubed. So I know the 4 is going to get to come out. X is just X. That's not a group of 3. That's not a group of 3. So they stay in. All right, so let's look at 27. That's 3 times 9. Oh, I did it again. I should know that 3 cubed is 27. So that would be a 3 on the outside. Now, x to the 4th. That's x times x times x times x. That's 4 of them. So I know I have a group of 3. So one of them gets to come out. And one's going to stay in. Y to the 5th. I got a group of 3, so one gets to come out. And that leaves 2 in, so I have y squared in. So again, I can just add my coefficients together. So I could actually rewrite this as 4 plus 3xy times the cube root of xy squared. Now remember, when it's like when you have like terms, you don't do anything to the variables. You're just adding and subtracting coefficients. All right, so now let's look at some of the ones with the multiplication or distributive property. We have 2 square root of a minus 3 square roots of b times 4 square roots of a plus 7 square roots of b. All right, so we're going to use the distributive property. 2 square root of a times 4 square root of a. That's going to be 8 square root of a times the square root of a. Hey, that's just going to be a. 2 square root of a times 7 square roots of b. That's 14. Remember the multiplication rules. That's going to be a times b. So that's ab. Negative 3 square roots of b times 4 square roots of a. It's going to be negative 12 square roots of those two together. A times b. Negative 3 square roots of b times 7 square roots of b. That's going to be negative 21. Square root of b times square root of b is just going to be b. So I'll end up with, let's see, we'll have 8a. And then I have 14 square roots of ab minus 12 square roots of ab. That's going to be 2 square roots of ab. And then minus 21b. Next one. X plus the square root of 5 squared. Now don't get caught up in the trap and think that you can distribute the square. No. Squaring something means to multiply it by itself. Now we distribute. X times x is x squared. X times the square root of 5 is going to be the square root of 5x. Square root of 5 times x is going to be square root of 5x. And then square root of 5 times the square root of 5 is going to be the square root of 25, which is just 5. Now I have one of these things and I have another of those things. That means I have 2 of these things. Now make sure that x is not under that in the radicand with the 5. It was on the outside. And then plus 5 at the end. One last example here. Number 6. Let's try x plus square root of 3, x minus square root of 3. I hope you notice that sum and difference. We've seen that before. I think that had a special name. If we think back on the Wayback Machine, those are called conjugates. X times x is going to give me x squared. That's going to give me a negative square root of 3x. Square root of 3 times x is going to be square root of 3x. And then square root of 3 times the negative square root of 3 is going to be negative square root of 9. Oh, that's just going to be a negative 3, isn't it? And we have the x squared. I have negative square root of 3 times x plus a positive square root of 3 times x. Hey, they cancel out. Now, just to remind you, that happens every time you have a conjugate.